Hi everyone. Today I'll be discussing on something that is both practical and fascinating. That is simulation of signals and systems using MATLAB or Python. So we have all learned about signals and systems theoretically in classes, but sometimes it's hard to actually see how they behave. That's where simulation comes in, which helps us visualize and experiment with concepts that we usually only see on paper. Now, coming to the first one, that is why simulate signals and systems. So signal processing is everywhere in communication systems, control systems, even in audio or biometrical devices. By simulating, we can test algorithms, analyze system behavior, and even prototype designs before moving to real hardware. And this saves time, reduces cost, and most importantly, helps bridge the gap between theory and practice. Now, coming to the next one, that is MATLAB. And why is it considered the industry standard for signal processing? Now, MATLAB is a tool that was created by Network and it is a very powerful piece of software. Now, it has specialized toolboxes like the signal processing toolbox and the SB system toolbox that makes everything faster and more reliable. MATLAB's metric-based environment makes it perfect for manipulating signals, and with Simulink, you can even simulate complete systems from sensors to filters to communication links. And this MATLAB is widely used by professionals and researchers because it provides accuracy, visualization tools, and easy prototyping all in one place. Oh, so now coming to the next one, that is Python. So Python is an open source powerhouse for signal processing, and it is also considered an alternative for MATLAB. And why is it considered so is because it is completely free and super flexible. Python uses libraries like NumPy, SkyPy, and Matplotlib for signal processing and visualization, and even has tools like Lipusa for audio analysis. The best part is it integrates beautifully with machine learning and data science, so you can mix signal processing with AI or IoT applications easily. So while MATLAB is structured and professional, Python is more customizable and community driven. Now, coming to the next one, that is key signal processing concepts. Some of the key concepts that we simulate include convolution and correlation, which show how systems correspond to signals. We also simulate Fourier, Laplace, and Z transforms to move between time and frequency domains. Then there's filtering, sampling, and interpolation, all essential for understanding how digital signals are processed and reconstructed. Through these simulations, we can clearly visualize what happens inside systems we design. And now coming to the practical comparison between MATLAB and Python. So when we compare both, MATLAB gives a unified environment with instant visualization and strong toolboxes. Python, on the other hand, offers flexibility, customization, and no cost. So in short, we can say that MATLAB is great for industrial large-scale projects, while Python is ideal for research, education, and rapid prototyping. Both are excellent. It just depends on what you want to use and what you need. So here we can see an example use case where says that design a low-case filter showcasing each platform's strength. So here you can use MATLAB as it excels in speed and GUI tools, while Python offers more customization and cost effectiveness. Now, now integrating MATLAB and Python. So what can be even better when we can use both together? So here we can leverage by using MATLAB's advanced toolboxes with Python's flexibility in open source ecosystem. And we can also use the best of both worlds, where MATLAB's algorithms can be leveraged within Python's applications or Python's data science tools inside MATLAB. And we can also collaborate between teams with different preferences and project requirements. So this way you can get MATLAB's precision and toolboxes along with Python's flexibility and AI capabilities, where we can use the best of both worlds and bring a better outcome. Now, now to get started, you can go to the MathWorks website. That is the official creator of MATLAB, where you can find some trial versions and you can implement on it. For me, I've personally used the MATLAB's on ramp for learning MATLAB, and you can also go with that. And for Python, you can use the Python distribution, which is number of libraries like NumPy, SkyPy, Matplotlib, and Liposa. So there are tons of online courses that you can also take from Coursera, and there's also plenty of free resources in YouTube. from where you can learn many sources of things about MATLAB and Python. Uh, so to wrap it up, MATLAB gives you industrial power and reliability, while Python offers freedom and flexibility. And if you combine them, you can take your simulation to an entirely new level. That's all for today's presentation. Thank you for watching, and I hope that it helps you see how signal simulation brings theory to life.